So today we are going to discuss about double angle identities. So I've prepared some examples and some formulas so that will help you with your problems with double angle identities. So first, let's discuss the formulas. The first formula will be for sine, which is sine 2 theta. Sine 2 theta equals to 2 sine theta times cosine theta. The second will be for cosine, which has three formulas. Cosine 2 theta is equals to cosine squared theta minus sine squared theta, which I actually really recommend because it is the easiest. Or if you want, you can use 2 cosine squared theta minus 1 or 1 minus 2 sine squared theta. And the last will be for tangent. Tangent 2 theta is equals to 2 tangent theta over 1 minus tangent squared theta, as long as tangent theta is not equal to positive and negative 1. And now let's discuss our examples. Our first example will be tangent theta is equals to 4 over 3, as in the condition of the theta is not supposed to be less than 0 degrees and 90 degrees, and you are required to find sine 2 theta. Our second example will be cosine theta is equals to 12 over 13 with the condition of theta not being less than 270 degrees and 360 degrees, and you are required to find sine 2 theta and tangent 2 theta. And for the third example, sine theta is equals to 630 degrees, and you are required to find sine 2 theta and cosine 2 theta. And now let's solve for example number 1. For example number 1, we will be using this formula, which is for sine. Now, as we all know, tangent is y over x. So now all we need to do is to find for r. So let's use the Pythagorean theorem. R squared equals to x squared plus y squared. So r squared is equals to 4 squared plus 3 squared. And then r squared is equals to 16 plus 9. R squared is equals to 25. Square root, r equals to 5. Now let's solve for sine 2 theta. So sine theta is equals to y over r. So sine 2 theta is equals to 2 over 4 over 5 times cosine theta. So 3 over 5. So 2 times 12 over 25 will be 24 over 25, and that's just sine 2 theta. And now we will solve for the second example. For this, we will use two formulas, for sine and for tangent. So cosine is x over r. So now we need to find for y. So let's use the Pythagorean theorem again. R squared is equals to x squared plus y squared. 13 squared is equals to 12 squared plus y squared. 169 is equals to 144 plus y squared. 169 minus 144 equals to y squared. So 25 equals to y squared, square root, 5 equals to y. And since it is according to the condition in the fourth quadrant, y will be negative. So now let's look for sine. So sine 2 theta is equals to 2 times negative 5 over 13 times 12 over 13, which will be negative 120 over 169. Now let's solve for tangent to theta. So tangent to theta, so given x equals to 12, y equals to negative 5, r equals to 13. So according to the formula, 2 tangent theta is equals to 1 minus tangent square theta. So 2 times negative 5 over 12 over 1 minus negative 5 over 12 squared. So 10 over 12 over 1 over 1 minus 25 over 144. Now you need to get the LCD for this. So 144. So 144 will be the denominator. So 144 will be here and then minus 25. So then it will be 10 over 12 over negative 119 over 144. Now let's multiply 10 over 12 times 144 over negative 119. So let's cancel 12. Now it will be negative 120 over 119. And that will be for the second example. And now let's solve for the third example. We are required to find for the sine and cosine. So sine 630 degrees. First we have to get the half of 630 degrees because this will be double angles. So sine 2 times 315 degrees. The formula will be 2 sine theta times cosine theta. So 315 will be on the fourth quadrant, which means y will also be negative. So sine 315 will be equal to negative square root of 2 over 2 because 315 is a multiple of 45. Now let's solve. So 2 is multiplied to negative square root of 2 over 2 times square root of 2 over 2. So 2 times negative square root of 4 over 4. Then 2 times negative 2 over 4 will be negative 4 over 4 equals to negative 1.